Hi guys, today we're going to be working on section 6.5, day 1 notes. In section 6.4, you had to graph the cosine and sine function and then some transformations of them. So in this section, they're going to want you to kind of figure out the original main graphs of the other 4 trig functions, the tangent, the cotangent, the cosecant, and the secant functions. So we kind of have to know their original graphs in their original form inside and out, all right? And what their original first cycle or period is going to look like. All right, so we're going to do the tangent function first. I just want to remind you of a couple things. The way the tangent ratio got redefined on the unit circle was the tangent of an angle was equal to the y-coordinate over the x-coordinate, because we're going to use that when we kind of go around our unit circle to kind of fill it in and figure out what our ratios are at each angle. And then the tangent of a 45-degree angle, which is the same as the tangent of pi over 4 radians, the tangent of a 45 or pi over 4 was a ratio of 1. So keep that in mind because that's going to kind of help us to fill in the gaps that we need to create the graph of the tangent function, okay? All right, so here we go. I've given you a list of inputs to plug in, and then we'll see what ratios come out. So here we go, ready? If we plug in, we're gonna start at 0. If I take the tangent of 0 radians, well, at 0 radians, the ordered pair is 1, 0. So the y-coordinate over the x-coordinate, 0 over 1, gets you a ratio of 0 out. 0 over 1 is 0. All right, at pi over 4. Pi over 4 would be a 45-degree angle in quadrant 1. So the tangent of a 45-degree angle is 1, and the tangent ratio is positive for angles in quadrant 1, so that's positive 1, okay? All right, pi over 2, the tangent of pi over 2. Well, at pi over 2, y over x is 1 over 0, which is an undefined ratio. So we get an undefined ratio there, which means technically that's an angle that you should not have plugged into the tangent function. So that's technically an angle that is not in his domain, but we'll get back to that. All right, 3 pi over 4. 3 pi over 4 is a 45-degree angle that landed in quadrant 2. So the tangent of a 45-degree angle is 1, but then the ratio for the tangent function is negative for angles that landed in quadrant 2. All students take calculus, tangent is negative. So that would be negative 1. All right. What about pi? You plug in pi, the tangent of pi radians. Well, this is where pi radians land. So y over x is 0 over negative 1. That's a ratio of 0. All right, 5 pi over 4, your fifth 45-degree angle, lands in quadrant 3. So the tangent of a pi over 4 is 1, and then the ratio is positive for angles in quadrant 3. All students take the tangent function gets you a positive ratio for angles in quadrant 3. All right, what about 3 pi over 2? The tangent of 3 pi over 2 lands right there. So the tangent of 3 pi over 2 radians is y over x. Negative 1 over 0 is undefined. What's up, bud?
I'm so happy I just got a legendary pet.
I
got a dragon.
Oh, you got a dragon. All right, cool, bud. All right, sorry, my son was talking to me. All right, so now we plug in 7 pi over 4. Also, so clearly that was another angle that you should not have plugged into this function. So that's another angle that's not in his domain. All right, 7 pi over 4. 7 pi over 4 is your seventh 45-degree angle. 1, 2, 3, 4, 5, 6. Your seventh 45-degree angle lands in quadrant 4. So the tangent of a 45-degree angle is 1, and then the tangent function gets you a negative ratio. All students take calculus, right? So the tangent ratio is negative for angles in quadrant 4. So that's negative 1. All right, let's plug in 2 pi. The tangent of 2 pi radians brings you all the way back around in one complete circle. 2 pi lands right here in the same spot as 0. So y over x, 0 over 1 is 0. All right, we're going to go to our ninth 45-degree angle. So if you remember, this is technically your 8th 45. Your 8 pi over 4 makes 2 pi. So your 9th lands right here in the same spot as pi over 4. So the tangent of pi over 4 is 1. And since he landed in quadrant 1, the ratio is positive. All right, and then 5 pi over 2, your fifth 90-degree angle, if you will, your fifth pi over 2, 1, 2, 3, 4, 5, your fifth 90-degree angle is right up here in the same spot as 1 pi over 2, and then y over x, 1 over 0 is another undefined ratio. Oops. Okay, so again, that's another angle that you should not have plugged into the tangent function. That is another angle that would not be in his domain. All right, let's go a little bit into the negative. So now we're rotating clockwise around the unit circle. Negative pi over 4 lands right here in quadrant 4. So the tangent of a pi over 4 is 1. And since you landed in quadrant 4, the ratio is negative. Okay? Negative pi over 2 is right here. It lands in the same spot as 3 pi over 2. Y over x is undefined. So that's another angle that you should not have plugged in to the tangent function. Okay, negative 3 pi over 4, your negative third 45-degree angle. 1, 2, 3. This is negative 3 pi over 4. So the tangent of a pi over 4 is 1. And since it landed in quadrant 3, the ratio is positive, right? All students take. So tangent is positive for angles that land in quadrant 3. All right, negative pi is right there. Y over x is 0 over negative 1. That's 0. Okay? Negative 5 pi over 4, your negative fifth 45-degree angle, negative 1, negative 2, negative 3, negative 4, negative 5 pi's over 4 lands right there in quadrant 2. So the tangent of a pi over 4 is 1, and since it landed in quadrant 2, the ratio is negative. All students, tangent is negative for angles in quadrant 2. All right, and then last, your negative 3 pi over 2, your negative third pi over 2, your negative third 90, the tangent of negative 3 pi over 2, negative 1, negative 2, negative 3 pi over 2 lands right here in the same spot as positive pi over 2. So y over x, 1 over 0 is another undefined ratio. So that again is another angle that you should not have plugged into the tangent function. That's another angle that is not in his domain. Okay, so let's lay this out on our graph and plot it. So because if you remember, the tangent and cotangent function had shorter periods, they took less units to repeat themselves. I kind of had to have shorter subintervals. So we're going to count from 0, and then we're going to count by pi's over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and so on. All right, so let's label our x-axis. 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi, 9 pi over 4, and then 10 pi over 4, which is really 5 pi over 2. All right, and then I'm going to count by pi's over 4 in the negative direction. That's going to be negative 1 pi over 4, negative 2 pi over 4, which is negative pi over 2. Oops, negative pi over 2. Negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, and then negative 6 pi over 4, which is negative 3 pi over 2 when you reduce it. Okay, perfect. All right, and then we're going to go, I have my 1 and my negative 1 marked. Okay, let's go. Let's plot our points. Ready? And let's see what this graph is going to look like. So when 0 went in, 0 came out. So 0, 0 is on the graph. Pi over 4 went in and 1 came out. So pi over 4, 1. Pi over 2, undefined. When pi over 2 went in, an undefined ratio came out, which means it does not exist there, and it creates a vertical asymptote. The graph will not exist when x is pi over 2. There will be no ratio that can come out that is definable. All right, 3 pi over 4, negative 1 came out. Okay, pi went in and 0 came out. 5 pi over 4 went in and 1 came out. And then when 3 pi over 2 went in, another undefined ratio came out. So another spot where the graph does not exist, creating a vertical asymptote. All right, 7 pi over 4 went in and negative 1 came out. So you can kind of start seeing a pattern in the outputs as they go. Like right here, you had 0 and then 1 and then undefined. And then negative 1 and then 0 and then 1 and then undefined. So see how this 0, 1, undefined? All right, we haven't seen the other side of this graph yet to see the full pattern. All right, so then 2 pi went in and 0 came out again. 9 pi over 4 went in and 1 came out. And then 5 pi over 2 went in and an undefined value came out. Okay, we're going to stop. Even though it would keep on going, you can just keep plugging angles in and create more outputs. All right, let's go back this way. Negative pi over 4 went in and negative 1 came out. So that's that point right there. Negative pi over 2 went in and another undefined value came out. So another asymptote is created, another spot where your graph will not exist. All right, negative 3 pi over 4 went in and 1 came out. Negative pi went in and 0 came out. negative 5 pi over 4 went in, and negative 1 came out. Oops. And then negative 3 pi over 2 went in, and an undefined value came out again. So yet another spot where the graph is undefined, and another vertical asymptote is created. So when you want to see what happens to this graph, remember, we read a graph from left to right. So we connect dots from left to right. So in a sense, from left to right, it's going to go from this dot to this dot, to this dot, and then it's gonna hug that asymptote. And then it's gonna go from this dot to this dot to this dot, and then hug that asymptote. So it creates a bunch of these kind of like swirly curves, almost like, I don't know how I want to describe it, but it's got this nice little curve flow to it. So again, now the graph is undefined, and now again, from left to right, it's gonna go from this dot, my marker, from this dot to this dot to this dot, and then hug that asymptote. And then it's going to go from this dot to this dot to this dot, and then hug that asymptote. So it's going to create a bunch of these repetitive curves. All right, so again, it's going to go from this dot to this dot to this dot, and then hug that asymptote, and then from here to here to there, and then hug that asymptote. Okay, and the same thing, you can just create that graph again and again and again. So this curve just gets repeated over and over and over every so many inputs, okay? And this is what the graph of the tangent function looks like. So you can see from left to right, as x gets bigger, y gets bigger. So this is considered to be, on each cycle, an increasing function, okay? All right, so what is the domain? Well, think about it. The domain are all the angles that you're allowed to plug in so that nothing bad happens. Well, guys, a lot of bad stuff happens at a lot of x values. So if you look, x is not okay when x is pi over 2. It's not okay when x is 3 pi over 2. It's not okay when x is 5 pi over 2. It's not okay when x is negative pi over 2. It's not okay when x is negative 3 pi over 2. So the domain is x cannot equal. Who's the first bad angle when you think about starting at 0 and working this way? The first bad one is pi over 2. X cannot be pi over 2. And then plus or minus in either direction, how far away is the next bad angle? Well, think about it. Pi over 2 is like 90 if you think about it. And 3 pi over 2 is 270. So how many degrees live in between 90 and 270? 180, which is pi radians. So every pi radians, there's another bad angle. So plus or minus pi radians times k rotations away from him. Okay, so that's what x is not allowed to be. So basically, x is not allowed to be 1 pi over 2, 3 pi over 2, 5 pi over 2. The next one is 7. It's not allowed to be odd integer multiples of pi over 2. Odd integer multiples of pi over 2. Those are going to be all bad x values for this graph and his domain. Okay, before I go any further, let me fill the range in. The range, though, if you look at the y values that live on each separate curve, they're going to go to negative infinity to infinity every single time. So that's going to be his range. His range is all real numbers. There might be a lot of bad angles that you're not allowed to plug in, but no matter what, the angles that you are allowed to plug in are going to create ratios from negative infinity to infinity. Okay, before I go any further, I just want to show you what we consider to be one period or one cycle of the tangent function. Starting at 0, 0, the origin, and working your way right and left, this one section right here is considered to be his first cycle, his first period. It's one cohesive piece of his graph starting at the origin. So this is what your first cycle or your first period of the tangent graph is going to look like. This is going to be what you use for your transformations. The point that live on this first cycle is what we can use to transform him. All right, so again, this is what one cycle or one period would look like, okay? All right, perfect. All right, what about his x-intercepts? Well, he's got a lot. How many times does he cross over the x-axis? Here, 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 here. He's going to cross over infinitely many times. So he's going to have infinitely many x-intercepts. So how can we label them? Well, the first x-intercept is at 0. The next one is at pi. The next one is at 2 pi. The next one would be at 3 pi, and then 4 pi, and then 5 pi, and then even this way, 0, -1 pi, -2 pi would be your next one. So your x-intercepts are x equal, they start at 0, and then plus or minus, how far away is it from one x-intercept to the next? Well, from 0 to pi, that's pi radians. From pi to 2 pi, that's pi radians. So plus or minus pi radians away will be the next one, times k rotations, okay? Or you can also say the x-intercepts are integer multiples of pi. Multiples of pi. Integer multiples of pi, okay? All right, well, what is his period? How many inputs do you have to go until the graph starts to repeat itself? Well, we already have talked about his period and the fact that it's not 2 pi radians, it's quicker. So if you look at your first cycle, right, these are the outputs that come out, right? Undefined came out, then -1, then 0, and then 1, and now you're back to an undefined. And now -1's gonna come out, and then 0's gonna come out, and then 1's gonna come out, and then you're back to an undefined. And then -1's gonna come out, and then 0's gonna come out, and then 1's gonna come out, and then you're back to an undefined. So that is what your outputs look like when they start to repeat. So how many units do you have to go for the graph to repeat? Well, think about it. If this is his first cycle right here, how many units live on this cycle? I went from pi over 2 to negative pi over 2. So 90 this way, negative 90 that way, 90 and 90, that's 180. That's pi radians that live in between negative pi over 2 and pi over 2. So the amount of inputs that you have to go to create one cycle is pi radians, right? Think about it. I went from 1 pi over 2 to 3 pi over 2. How many pi's over 2 live in between them? Well, 3 pi over 2 minus 1 pi over 2, that's 2 pi's over 2. What's 2 pi over 2? It's pi. There's pi radians that live in this cycle. All right, so his period is pi. Every pi radians, the graph will start to repeat. And that's why his subintervals are different. If you take his period, right, which is pi, and divide it by 4 into your 4 main subintervals, well, the period pi divided by 4 means that you're going to count by increments of pi over 4 to create your subintervals. And I did. I counted by 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's your counting increment to create your subintervals because it's your period divided into 4 subsections, subintervals. All right? Now, the amplitude is supposed to be half the distance between the highest and lowest point, right? It's supposed to be like how many units up and how many units down from that midline. Well, because your graph goes to infinity to negative infinity, there's no amplitude that we could say is half the distance from the highest and lowest point when you're going from infinity to negative infinity. So his amplitude is just NA. It's non-applicable here in the fact of that it's going to infinity and negative infinity. All right, what about your y-intercept? It crosses the y-axis right there at 0, 0. So that's kind of like where I kind of like to think that it almost starts, even though like technically we go there. All right, remember the tangent function for every xy that lived on his graph, right? Pi over 4, 1. There was the opposite of x, the opposite of y, negative pi over 4, negative 1, which makes him an odd function with symmetry to the origin. Okay, you have vertical asymptotes. You have infinitely many of them, right? All the angles that are not in his domain create a vertical asymptote. So you're going to have VAs at all the x values that are not in his domain. So you are going to have VAs at x equals pi over 2 plus or minus pi times k rotations away, right? Odd integer multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2. Those are all going to be vertical asymptotes. X will equal odd integer multiples of pi over 2. Okay? All right, your 4 main subintervals. If you look at your first cycle only. Oh, I want to be able to do that again like I did last time. Look at the first cycle. Hold on, give me 1 second. All right. So if you look at his first cycle, right? From negative pi over 2 to pi over 2. That's his first cycle. And we have created 4 subintervals. 1, 2, 3, 4 subintervals have been created, okay? So one set subinterval is from negative pi over 2 to negative pi over 4, this subinterval right here. So we can't include negative pi over 2 because he creates an undefined. Negative pi over 2 to pi over 4 is one subinterval. Your negative, sorry. Your next subinterval is from negative pi over 4 to 0. And again, this is supposed to help you with your transformations to see your original first cycle. All right. Then we go from 0 to pi over 4 as our next subinterval. And then your last subinterval is from pi over 4 to pi over 2. Pi over 4 to pi over 2, but not including him because he creates an undefined output. All right, so again, if you just take your period, which is pi units, and divide it by 4, you're going to count by increments of pi over 4 to create your subintervals. Okay, so that's going to leave us with, again, 5 key points that you're going to be able to use on the first cycle to create your transformed graphs. So your first key point technically isn't even a point, it's a VA. It's negative pi over 2 went in and an undefined ratio came out. So negative pi over 2 is your first key point, comma, undefined. And it was a vertical asymptote. Okay, your next key point is negative pi over 4, negative 1. All right, and he was just a point on the graph. Your next key point is 0, 0. Your next key point is pi over 4, 1, right there. Pi over 4 went in and a ratio of 1 came out. And then your last key point, like I said, it's not even really a point, it's a VA, is pi over 2 went in. And an undefined ratio came out, so he's another vertical asymptote. All right, so that are your 1, 2, 3, 4, 5 key points that you should be able to use when you go to transform the tangent function. You can just make the changes to these 5 ordered pairs as per whatever happened to the equation when you go to transform it, okay? All right, perfect. Okay, well, when you go to graph the cotangent function, the easiest way to graph cotangent is, think about it. It's the reciprocal of tangent. So when all of these angles go into the cotangent function, the reciprocal of these ratios come out. So all we have to do is fill in these boxes by taking the reciprocal of these numbers, because that's what would happen, all right? So let's fill them in really quick. So when 0 went into tangent, 0 came out. So if 0 goes into cotangent, the reciprocal of 0 comes out. Well, guys, think about 0 as 0 over 1, 0 over any number. What's the reciprocal of 0 over a number? It would be a number over 0, which would be undefined. So undefined comes out of the cotangent function when you are plugging in the angle of 0 radians. And again, if you want to think about your unit circle, remember cotangent was the x coordinate over the y coordinate, okay, if you want to go back and use your unit circle. But the easiest way is just to reciprocate his outputs. All right, so when pi over 4 goes into cotangent, the reciprocal of this ratio would come out. So when pi over 4 went into tangent, 1 came out. So the reciprocal of 1 comes out of cotangent. Well, the reciprocal of 1 is 1. All right, so when pi over 2 goes in, when pi over 2 went into this, an undefined ratio came out, which means that it was something divided by 0. So flip that over, 0 divided by something is 0. So now 0 comes out of the cotangent function when pi over 2 goes in. All right, 3 pi over 4 went in, and it goes in, and then the reciprocal of negative 1 comes out, so that's negative 1 still. All right, when pi goes in, when pi went in, 0 came out, so the reciprocal of 0 is undefined. So now an undefined comes out. All right, when 5 pi over 4 goes in, the reciprocal of 1 will come out, which is 1. All right, when 3 pi over 2 goes in, the reciprocal of undefined will come out. Well, if it was undefined, it was something divided by 0. So flip that over, now it's 0 divided by something, and that's 0. Okay, when 7 pi over 4 goes in, the reciprocal of negative 1 will come out, which is still negative 1. When 2 pi goes in, the reciprocal of 0 will come out. The reciprocal of 0 is undefined. So now undefined comes out. And then when 9 pi over 4 goes in, the reciprocal of 1 will come out. So that's still 1. When 5 pi over 2 goes in, the reciprocal of undefined. Well, undefined would be something divided by 0. Flip that over, and that's 0 divided by something, so that's 0. Okay, let's go the other way. When negative pi over 4 goes in, the reciprocal of negative 1 will come out, which is still negative 1. When negative pi over 2 goes in, the reciprocal of undefined will come out. The reciprocal of undefined is 0. Okay, when negative 3 pi over 4 goes in, the reciprocal of 1 will come out, which is 1. When negative pi goes in, the reciprocal of 0 will come out, which will be undefined. Okay, when negative 5 pi over 4 goes into the cotangent, the reciprocal of negative 1 will come out, which is negative 1. And then when negative 3 pi over 2 goes in, the reciprocal of undefined will come out, and the reciprocal of undefined is 0. Okay, all right, let's plot our x-axis. And again, the cotangent has a shorter period as well, just like the period. So we count by pi's over 4. So let me label my x-axis. I have 0. I'm counting by 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi, 9 pi over 4, and then 10 pi over 4, it reduces to 5 pi over 2. And then I can go back the other way. I have negative 1 pi over 4. I have negative 2 pi over 4, which is negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, which is negative pi, negative 5 pi over 4, and then negative 6 pi over 4 reduces to negative 3 pi over 2. All right, let's plot our points. And again, I have my 1 and my negative 1 marked. Okay, this time, when 0 goes into the cotangent function, now an undefined comes out. So the cotangent starts at an undefined. So that's the major difference between tangent and cotangent. Tangent starts at 0. He does not start at an undefined. Cotangent starts at undefined, okay? All right, pi over 4 went in and 1 came out. Pi over 2 went in and 0 came out. Where did I go? 3 pi over 4 went in and negative 1 came out. And then pi went in and we're back to an undefined. So you can clearly see that in between 0 and pi, you have this first cycle, okay? And it takes pi radians to create it. And now we should see these outputs start to repeat again, okay? So when 5 pi over 4 went in, 1 came out again, right? You have that repeating output. So now when 3 pi over 2 went in, 0 came out. So now you're back to the next output. When 7 pi over 4 went in, that negative 1 came back to going out. So you can kind of see that pattern in your outputs. All right, 2 pi went in and an undefined ratio came out. All right, 9 pi over 4 went in and 1 was back. 5 pi over 2, 0. Your next one would be what? That was your 9 pi over 4, your 10 pi. Your 11th pi over 4, your next angle would create that 0, that negative 1 to come out. And then your 12th pi over 4, which is 3 pi, is going to make that next undefined value come out. So you can just continue your cycle, okay? Let's go back this way. Negative pi over 4 went in and negative 1 came out. Negative pi over 2 and 0. Negative 3 pi over 4 and 1. So again, you can kind of, let's do this one. Negative pi and undefined. So again, undefined, 1, 0, negative 1, undefined. 1, 0, negative 1, undefined. 1, 0, negative 1, undefined.
Can I see
What's up, bud?
Cameron Jackson?
Go ahead, bud. You should be laying down. It's very, very
Can
late.
I see?
You can try. All right, we can go again this way. Negative 5 pi over 4 went in and negative 1. Negative 3 pi over 2, 0. And again, you should already know that if this was your negative 5th pi over 4, your negative 6, your negative 7th pi over 4 should create that 1 to come out. And then your negative 8th pi over 4, your negative 2 pi is going to have that asymptote again. All right, you can already predict the outputs because of the pattern. All right, and then from a left to right perspective, cotangent looks like this. All right, so it kind of looks like tangent went this way, cotangent goes this way. It's because of the shift in those undefined ratios. Okay, and that's what your cotangent graph is going to look like. All right, let's fill in his information. Okay, so again, starting at 0, this is what we consider to be the first cycle of cotangent right here from 0 to pi. This is your first cycle. Okay, all right, so the domain. Well, look at it. He's got lots of bad angles. X can't be 0, X can't be pi, X can't be 2 pi, X can't be 3 pi, and so on. So X is not allowed to be 0, plus or minus, the next bad angle is always pi radians away times k rotations. All right, so technically, X is not allowed to be an integer multiple of pi. Okay, all right, what about your range? Your range is still the same as tangent. It's still going, your y's from negative infinity to infinity. And if you think about one cycle, the cotangent is a decreasing function, okay? All right, what about your x-intercepts? Your x-intercepts, it crosses the x-axis at 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. So x will equal, the first one is pi over 2, plus or minus, and again, there are infinitely many of them. There's one here and here. How far apart? Well, 90 is the first one if you want to think about it in degrees, 90 and then 270. So again, that's 180. That's pi radians that live in between each x-intercept. So plus or minus pi times k revolutions or rotations. All right. So again, it's going to be odd integer multiples of pi over 2 are all your x-intercepts. They are odd integer multiples of pi over 2. Okay? All right, if you know your cotangent, just like tangent, is an odd function with symmetry to the origin, right? For each xy, there is the opposite of x, the opposite of y that lives on this graph. Same thing. 1 pi over 4 and 1 went in and out, and then negative pi over 4, negative 1 live on his graph. All right, the period. How many units does it take to create one of these cycles? Well, it's clear as day. It goes from 0 to pi. So the period is pi radians. All right, again, your amplitude is NA because of this whole going from infinity to negative infinity. There's no half the distance between the highest and lowest point. All right, your y-intercept, it does not have one because there's a VA at the y-axis. All right, your vertical asymptotes are the same as all the angles that are not in his domain. All the angles that are not in his domain cause VAs. 0, pi, 2 pi, and so on. Integer multiples of pi or 0 plus or minus pi times k rotations will all be VAs. X equals 0 plus or minus pi times k rotations, also known as integer multiples of pi, are all VAs. All right, yours 4 subintervals. Again, if you take his period pi and divide it by 4 into 4 subintervals, you're going to be counting by increments of pi over 4 to create his first cycle and to create those 5 key points. All right, so his subintervals are 1, 2, 3, 4. From 0 to pi over 4 is 1 subinterval. From pi over 4 to pi over 2. All right, from pi over 2 to 3 pi over 4. And then from 3 pi over 4 to pi is your last subinterval. Oh, I should not be including pi because he creates an undefined. All right, and then your 5 key points. Technically, your first key point is your VA, so 0 goes in, undefined comes out. And it's a vertical asymptote right when the first cycle starts. Your next key point is pi over 4 went in and 1 came out. All right, your next key point is pi over 2 went in and 0 came out. Your next key point is 3 pi over 4 went in and -1 came out. And then your last key point is that when pi went in, an undefined came out. And that's another VA. And those are the 5 ordered pairs you can use to create his transformations in the future when you want to whip up a quick sketch of his first cycle. Okay, that is your cotangent graph. I'm going to come back and do the back page of the notes for cosecant and secant. All right, I'll be back.